My dear friends, once again, good afternoon. So we'll be starting the second portion, and this again, here again, I'm going to show you SPSS, but I will give you the hint how it will be used in the SPSS later on. But for SPSS, first of all, you have to know particularly what is continuous variable, what is discontinuous variable, what is metric data, and then what is nominal data, and then how to enter the data, then how many levels should be there. Once you know how to enter, particularly the level and particularly the scale, then everything is okay. But sometimes we got confused about the level, male, female, then about the urban, rural, about the designation. There comes level, no? Sometimes we got problem in the analysis in the spaces. Once you know how to enter the level and how many variables you're using, how many variables you want to control, then it's okay. Once you know, the rest of the things is in the fingertip, but you should know if I'm applying chi-square, then what are the conditions to be fulfilled? If I'm applying t-test, then what are the conditions to be fulfilled? Once you know those conditions, then when even when you do for your thesis work, everything, nobody will say it is wrong. I come across many research theses that they apply chi-square, but the cell value, some of the cell value are less than 5. See, chi-square says that cell value should be minimum of 5 or more than 5. But they have applied the chi-square. But if the cell value is less than 5, then what should be the correction factor? Yes, correction factor is there, then they should apply it. But in the case of SPSS, if the if in the case of chi-square, if the all the conditions are not being fulfilled, then you have to go for Fisher exact test. In the case of contingency, if all the chi-square contingency table, if all the conditions are not being fulfilled, then you have to go for livelihood test. So if these conditions are not being fulfilled, then alternative methods is available in the SPSS. So see, regarding the arithmetic mean median mode, don't worry, don't see, you just enter the data, click the descriptive strategy, so everything will come out automatically. But you should know when to use it. Now, when to use it, just remember my story of crossing the river. Instead of calculating the mode, the person had calculated arithmetic mean and tried to cross the river and get drowned. So there mode should be used. Most common diseases, most often use shoe size, most often purchase shirt size, and so on. So in those cases, you have to find the mode, not the limiting mean. Now coming to the test of significance. So then I was informed to cover chi-square test, then the t-test, one sample t-test, two sample t-test, pair sample t-test. And in the case of z-test, there are three cases, 3 or 4 cases. If time permits, I will cover all the cases. The F test, I will begin with the F test. So these things that I'm being asked to cover manually, not the SPSS, manually, I'm being asked to cover it. Now, let me first begin with some background about the research. So in the research process, what we did, first you have to identify the problem. Once you identify the problem clearly, then the rest of work is easy. When you identify the research problem, it should indicate the variable to be used. It should indicate the population to be used. It should indicate the type of research to be followed. Clear defined topics or clearly defined research problem indicates the variable or the research problem itself, variable. Are you going to measure in terms of anxiety? Are you going to study the stress? Are you going to study the socio-economic condition? There is a variable. Then your title will indicate the population of studies. Your title will also indicate whether yours is going to be experimental study or survey study or what type of study. So 3 things. The title, that is, while you identify the research problem, 3 things should keep in your mind. That your title should indicate the variable to be analyzed, then population to be studied, and the third thing is your type of research to be followed. After that, you'll be reviewing the literature, then you'll be making the formulating hypothesis. If, in the case of exploratory research, there is no need for hypothesis. Hypothesis is needed only for conclusive research and other research. But if your is exploratory nature, then hypothesis is not needed. Then after data collection, then you will be testing the hypothesis. Here in the 6th stage, my portion will be in the data analysis stage. You'll be doing the data analysis. There, if any hypothesis that you have formulated, then you have to do the testing. So First thing will guide the remaining steps. And my portion here will be not the sample size, not everything, but here will be test of hypothesis. Remember it. If your sampling design is not probability sampling, don't dream or don't think about going for testing of hypothesis. There's no use. If it is non-probability sampling, then your finding will be true only for that sample size. And you can't go for generalization. And hypothesis testing is mainly meant for generalization. Clear? So what is hypothesis? Hypothesis mean, when you talk about hypothesis, assumptions, some supposition to be proved or disapproved, some supposition or some assumption. Hypothesis may be defined as a proposition or set of propositions set forth as an explanation of the observed phenomenon. But some says that it is a conjectural statement, means it is a statement made on the basis of incomplete information between two or more variables. Simply hypotheses are assumptions to be tested. Okay, assumption to be, then how will you formulate the assumption? Assumptions are being formulated on the basis of the prior knowledge. Assumptions are being formulated on the basis of observations, prior knowledge. Okay, now you can see, I remember when I was working in a Malhotra group of company as a marketing executive, when I go down the road, then I suddenly think the more the market coverage, the more will sell revenue. A particular brand which is available at maximum outlets, and you compare with their sales, then the more the market coverage, the more will sell for this particular type of product or not. So I used to calculate correlation R. The more the market, the more it covers the market, the more it sells or not. If it is true, then we should insist the salesperson to cover all the outlets available in the city. और एक कहावत भी है, customer वो देखते हुए खरीदता है. Many times impulse buyer, suddenly they go to the market and then they found a particular brand, they like it, they purchase it. They don't have an intention of buying it before going to the market shop. But after going inside the shop, after seeing everything the display, they feel like buying it. So customer खरीदते है वही देखता है, वो देखता है वही खरीदता है. This was the language used in Bombay in those days. वो देखता है वही खरीदता है. So that means if your brand is having more market coverage, then more will be sold. If it is true or not, we tested, it was true. The more the market coverage, the more the dukan is being covered by the brand of yours, the more will be sell revenue. So correlation up, remember that. So then on what basis you frame the hypothesis? On the basis of normal hypotheses are formulated from observations of the researcher, from observation or from prior knowledge. And you can face it with your experience. The more younger the people wear colorful dresses. This can be a hypothesis. The more the young people, the people wear colorful dresses. Or some of the example, some of the hypothesis is large farms with richer resources are more multi-product farms. Employees of different banks have different level of stress. This we have done. Employees of different banks, you have different banks, and whether the level of stress are same or not. Here mean, we calculate the mean score of stress of different banks, and then we apply F test. When the sample is when the sample group is more than 2, you have to apply Anova. But Anova is for experimental research, but often we use for survey research also. See, mean score stress of ICI, mean score stress of Punjab Bank, mean score in the stress of UCO Bank. All these things are being calculated. We collected from Barak Valley. Around so many banks, I couldn't remember exactly. So as many banks as possible. Then their mean score of stress were being compared. And it was found that there was significant difference. The difference in the stress level of the employee from bank to bank. And we also calculated which bank is having the lowest stress level. So again, the male and the female employees have different level of stress. The male and female employees, female bank employees have different level of stress. Whether it's true or not, whether male has a higher level of stress or female has a lower level of stress. So in this case, male and female only, so you can go for T testing or J testing. Earlier people said that T testing is for small sample size. J testing is for large sample size. Nowadays, you will not find J test in the SPSS. Whatever we use for a small sample are also being used for large sample. All the t-testing now these are being applied for large sample also. Earlier for small samples, because t-testing was used because you have to calculate manually. When the sample size is very small, you can easily calculate the sample size, standard deviation. You can easily calculate the limiting mean. Sample size is very small. So t-testing was being done for small size manually. But nowadays, for large sample also, instead of z-test, t-testings are being used in airspaces. As I have said earlier, general hypothesis testing procedure. First one, state the null and alternative hypothesis. Then select the desired level of significance alpha, the level at which you want to reject the true hypothesis. 5% means out of 100, 5 times I will be rejecting a true hypothesis. Then selecting the appropriate test statistics, looking at the condition, looking at the type of data, looking at the scale on which data are being collected, which test statistics should be applied. For chi-square, certain conditions are there. For z-test, certain conditions are there. For Kolmogorov Smirnov d-test, certain conditions are there. For f-test, certain conditions are there. If the condition, the nature of the data fulfills the particular characteristics of a technique, then you apply the technique. So after that, you make a decision rule. If the value is this, then if the calculated value is this, then you will be accepting the null hypothesis. If the calculated value is this, then we will be rejecting the null hypothesis. The decision rules are to be framed. And the calculated value of the test statistics, you calculate it, then compare it with the reference to step 4, then draw the statistical conclusion. Now, as I have said that mean income of Silchar is 110, mean income of Karimganj is 100. So the difference of 10, whether this 10 is significant or not. If 10 is significant, then you may come to the conclusion that this difference is not by chance. True difference is also there. So the mean income of Silchar is more than that thereof mean income of Karimganj. But if whether this difference is not significant means what? This difference is by chance. In reality, there is no difference in the mean income of people, mean income of households of people of Barak Valley of Silchar. And this Karimganj, the household income of Karimganj and household income of Silchar are same. This difference is by chance. Or if the R is 0.65, whether R is significant or not. If it is significant, then in reality there is a relationship between advertising and sales. And if it is not significant, then this is by chance. You ignore the fact that there is a relationship. It's not so important. Not significant means not so important, forget it. Significant means important. You take into consideration while you take a decision. Yeah. Now, non-parametric test. In the case of non-parametric chi-square test is and should be applied on the data collected on the nominal scale or on non-metric scale. Non-metric scale means qualitative scale. You have metric scale and you do have nominal scale and ordinal scale are called non-metric scale. Nominal and the ordinal scales are called non-metric scale, which are not quantitative in nature. Quantitative in nature are data collected on metric scales. These are interval scale and ratio scale. Now, conditions for applying the chi-square test is data are nominally scale. Name 200 ml, 300 ml scale. To test whether a significant difference exists within the observed number of responses expected. What you expect and what you observe, and whether this difference is significant or not. If you look at the formula, OI observe minus expected. If there is any difference, whether this difference observe minus expected, whether this difference is significant. We are testing O minus E divided by the EI. So this is for formula, but in reality, we are checking whether the difference between the observed value and expect value, whether this difference is significant or not. And for this is for single sample. For two sample, you will be considering the contingency table. For single sample, simply chi-square goodness of fit is there. Chi-square goodness test or chi-square goodness of fit. So this is the formula. I means if you are having five observation, then I will be 1, 2, 3, 3, 4, 5. N will be 1, I 2, 5. Or you can forget this I. I means I will indicate how many observations are there. N will be total number of observations. Chi square, OI minus EI square by EI. This is the formula. Now you look at this question. You look at the question. A bottler does the bottling of 4 different sizes: 200 ml, 300 ml, 400. These are nominal. Just category. Nominal scale means just naming. 200 ml, 300 ml, 400 ml, 500 ml. From the bottler pass record record of their other soft drink, 10%, 35% purchases were made. For 200 ml, 10% sales were being made. For 300 ml, 35% were being made. For 500 ml, 30% were being made. The bottler is interested if this consumption pattern exists for a new soft drink. Now, this bottler is going to introduce a new soft drink. If there is a change in the consumption pattern, this could necessitate a change in the percentage of bottling sizes. Okay, if the same consumption pattern follows, then we'll be ordering 200 ml. We'll be using 200 ml this much, 300 ml this much, 400 ml this much of the new soft drink also. But if the consumption pattern changes, then our requirement of the bottle sizes will be different. So he just wants to see that whether our requirement of the bottle sizes will be same as before, or for the new cold drink we require a separate pattern of consumption of size of the bottle. Let me repeat once again. This bottler uses 200 ml, 300 ml, 400 ml bottles for selling their soft drink. Now, new soft drink has been introduced, and he wants to see that whether the same pattern of consumption will be followed. The way 10% for 200 ml, 30% for 300 ml. He wanted to see. The bottler decided to conduct a test market to determine the purchasing patterns of the new soft drink. Various bottle size of the new drink. Now, after a week of market testing, the data gathered were this one. For 200 ml, this much. So this is the observed. This is the observed. 200 ml, this much of sell. This much of sell. This much of sell. So do the figure from the test market indicate a change in the consumption pattern of the new week? Whether this pattern indicate a change in the consumption pattern. The first consumption pattern was 10% 200, 35% 300 ml, 25% 400, 30%. This was earlier. So the bottler was expected that new pattern, new soft drink will also follow this pattern. But let's see, in the case of observe, this is observe what they call. There was expected, this is observed. So whether there is any difference between observed and expected, whether there is any difference. If there is no difference, then the bottler will be happy. Oh, same pattern of same requirement of bottler will be there. So he will be ready for that. But if same pattern is not there, then he will be ready to plan the different bottle sizes for this particular soft drink. So let us do the hypothesis testing to see that the new soft drink follows a new pattern of consumption, or it follows the same as it is before. First step null hypothesis is, I have said that in all hypothesis testing, step 1, step 2, step 3, step 4, step 6, I will be following this. This is clearly prescribed by the marketing research by Luke Rubin, which is a foreign edition. So for systematic analysis, follow this step. First, state the null hypothesis, alternate hypothesis, select the desired level of significance, and so on. So first step, null hypothesis. There has been no change. Null hypothesis always say no change. There has been no change. There has been no change in the consumption pattern. Or suppose mean income is 100. Not different from 100 means what? Null hypothesis says that mean not different from 100. Not different from 100 means equal 100. There has been no change means no change means almost similar to what was happening earlier. So null hypothesis always say no. So there has been no change means if the way it has been following in the past, the same thing, the same pattern follows. Alternative hypothesis, there has been a change. Alternative hypothesis will just opposite to null hypothesis. That has been changed. The level of significance alpha is 5%. That means alpha 5% means 5 by 100. Out of 100 occasions, 5 times my process may be allowed to take allowed to make a 5% error. So here the level of alpha 5% means what? The entire process allow the mistake of error of 5%. Of all 100, allowable error is 5%. See, you have a friend, good friend. He make one mistake, okay, acceptable. Another mistake, acceptable. For how many mistakes you go on tolerating? After some time, you say enough is enough. We know no longer we are going to be friends. Up to what acceptable level of error? Up to 5% level of error is being accepted. That's why alpha level is 5%. When we say alpha equal 5% means error up to 5% is accepted. Beyond that, we are not going to accept. So you are going to test the hypothesis up to the permissible level of error of 5% only. Beyond that, you are going to reject. See, so alpha 5% means making a mistake of 5% out of 100. Up to that is admissible. Even your friends commit a small mistake, acceptable. But when you make more mistake, then you say enough is enough. Likewise, up to what level you are going to accept the mistake, error. So up to 5% error is acceptable. So for this chi-square is chosen, why? Because it is nominal data. It is nominal data. So what was the condition of chi-square? Data are nominal scale. Your 200 ml, 300 ml, 500 ml are nominal, just name, check only. To test whether a significant difference is within the observed and expected. Here, my intention is to check whether the patterns or the earlier pattern was following or the new pattern is following by comparison with observed and expected. So this is single data, single sample. So it fits chi-square. It fits chi-square. So chi-square is being chosen. Chi-square is chosen. Now decision rule. Decision rule. So here degree of freedom is always, in the case of contingency, R minus 1 into C minus 1. There is the for contingency table. Otherwise, degree of freedom is N minus 1 always. N minus 1. For two sample, N plus 1, N2 minus 2. Why you will say why minus 1 always? Why minus 1 always? Now I'm giving you, I would like to write it, but I'm giving you, without violating the restriction of x1 plus x2 plus x3 plus x4 equal to 100. To how many values you have the freedom to assign? Let me repeat once again. X1 plus x2 plus x3 plus x4 equal to 100. Go to 100. Now that means on one side you are having unknown 4. My question is, how many variables you have the freedom to assign value? To how many variables, or simply how many values you have the freedom to assign? If you assign x1 value, x2 value, x3 value, automatically x4 value you can get it. X4 equal to 100 minus x1 value minus x2 value minus x3 value. When you have four values of a variable, x1, x2, x4, you can assign in your freedom 1, 2, 3. The remaining can be automatically calculated from the condition that x1 plus x2 plus x3 plus x4 equal to 100. So what is degree of freedom? The degree of freedom can be referred to as the number of freedom that we have in assigning the values to the variable without violating the restriction. The restriction was 100. So x1 plus x2 plus x3 plus x4, if I assign to these three values, x1, x2, x3, or x4, x3, x1, one value of x can easily calculated by 100 minus, if you transfer those values that side. So this is degree of freedom. So when you have a sample size of 5, then degree of freedom is 5 minus 1. When you have a sample size of 4 or 4 category, here you have one sample, but you have 4 category, 500, 400, 300, 200, 4 category. So 4 minus 1. So degree of freedom is 3. degree of freedom is 3. So at alpha 5%. No, you don't look at the table. Look at the table. For degree of freedom 3, and for 5%, 5% is 0.05. For 0.05. For 0.05%, the 4 degree of freedom, the 3 degree of freedom is 7.81. 3 degree of freedom 3. 0.5% in 0.05. Value is 7.81. 7.81. If the chi-square value calculated you are calculating is less than 7.81, the null hypothesis will be accepted. But some people says that here don't say that except you have to say like this, not rejected. They prefer the word not rejected. Then why? The reason is that you are calculating all these things on the basis of sample data, not on the basis of population data. So don't use the word accepted. There was a suggestion given by the expert, but we have been using right from the beginning accepted or rejected. So here I'm using it. If the calculated value here is less than, but remember in the S base, if the P value is less than the 0.05, then it is significant. Then you are going to reject the null hypothesis. But here it is just opposite. If the calculated is less than 7.81, null hypothesis will be accepted. And if chi-square calculated value is greater than 7.81, table value, null hypothesis will be rejected and alternative hypothesis will be accepted. Less accepted, greater rejected. Calculated value less than table value accepted. Calculated value greater than table value rejected null hypothesis. So this is the decision rule that you are framing in step 4 by looking at the table value. So since you know that your category is 4, 4 minus 1, 3. So degree of freedom is 3. Your alpha is 5%. Yeah, you have taken alpha as 5%. So here 5% means 0.05. Then 3 coming down. So 7.81 is the value. So table value is 7.81. 7.81. Calculated less, accept it. Calculated greater, reject it. Now expected. So what is here? Calculation. Here expected number of bottles. Expected. In the trial, total number of bottle trial was 1698,5683 plus 3945 plus total number of trial was all this in the trial. Now you look at this. Here expected total number of bottles corresponding to the 6s are 15. Total was 15980. But how much you are expecting? In the question 10 earlier 10% of this, 30% of this, 25% of this. So now you expected out of 15980, 10% of 200 this much, 35% of this much, and 400 ml this much. So earlier existing pattern was 200 ml 10% like this. Now even though you have a trial, even though you are making a trial, the total is 15980. 15980 total bottle. This total bottle when you try it 200 ml, this is observed values. But forget about the observed value. What was expected? What should be the expected value? Expected value is this. Now you make a tabulation. Observed values, expected values. So 200 ml observed value this one, expected. 300 ml observed expected. Now at the end you get the chi-squared. The summation, when you take the summation of O minus E squared by E, now 12.395 is the chi-square value. 12.395. So 12.3 statistical inference. Since the calculated 12.395 is greater than 7.81. Calculated greater means reject the null hypothesis, implies that null hypothesis is rejected and alternative hypothesis accepted. Now, what was the alternative hypothesis? What was the alternative hypothesis? There has been a change. There has been a change in the consumption pattern. So there has been a change in the consumption pattern of the various water. There is the sales of the new soft drink for the various bottle sizes are different. So there has been a change. So whether the new soft drink follows the same pattern or not, we tested and it was found that there was a change in the pattern. So accordingly, He will find the bottler will find the proportion of the sizes, and accordingly he will prepare. Oh, for this bottle size, for this new serving will be this much. This much people will be demanding. This much or the bottle size will be demanding. Accordingly, he can prepare it. So this is one sample. So the first topic given to me was for one sample. Now for two sample and which are independent. You look at this from the data. First, always you think one thing, that is, uh, you have to first you have to produce the descriptive statistics, and after that you have to apply the formula. Now, from the data given below about the treatment of 250 patients suffering from the disease, state whether the new treatment is superior to the conventional treatment. New treatment, favorable 140. Of 170 patient, new treatment give favorable 140, unfavorable 30. For the conventional all one, which we have been using, of the 80, 60 favorable, 20 unfavorable. Now, if you look at this is called contingency table. Rows into column, 2 rows, 2 column, and total number of observation 250. If at all you want to apply the chi-square for contingency table for independent samples. Now you are having two samples. One is those patients of 170 using new medicine, new treatment, and another sample of 80 using conventional. These two samples are independent because one sample is using new treatment, another sample is using conventional treatment, and total number of samples is 250. Now this is cell value 140, 30, 20. Here cell value is greater than 5. 30 is greater than 5, 140 greater than 5, 60 greater than 5. So 250, a total is greater than 50. Chi-square says that if the cell value is greater than 5, each of the cell value is greater than 5, and if the total number of item is greater than 50, then you have to apply the chi-square. Otherwise, you have to modify the formula by making Yates correction. So manually we used to apply Yates correction for having the cell value less than 5. But in the SPSS, if the cell value is less than 5 in some of the cases, then you can't apply chi-square. You have to apply Fisher-Exec test. But then in the case of contingency, again, if you find that there are some of the cell zeros are there, then you have to apply likelihood test. So not only knowing how to apply, you should also know how to interpret the data. So many times, without knowing why I am using this and why I am not using this, people started applying it. But it takes time for me to understand also. We started theoretically, later we switched over to SPSS, and we made a lot of mistakes. Later on, by attending various programs, some questions are being answered. Those questions lurking in my mind, many questions are being answered. So you have to go on attending. See, by attending one program, that is not sufficient. In one of the program attending, you may have confused and you may get some problem. By attending another program again, there may be another question. Go on attending, then in one after another, you go on asking the resource person why it is so and so. So they will help you to remove the many question mark that you have in the research methodology. And attending one or two training programs will not be sufficient enough to understand what is all about research. Still, I am yet to understand in totality about the analysis of data. So many tools are there yet to be covered. But remember, for chi-square, cell value should be less than 5, total should be greater than 50. Then you apply the chi-square. Now this is called contingency table, and these are observed value. So we are going to test which one is more favorable. We are going to test whether there is any difference. We are going to see whether there is any significant difference in the treatment of the two. Whether there is any significant difference in the efficacy of the treatment of this new and conventional. New treatment, conventional, whether there is a difference or not. We're going to see. Now, sometimes for examination, they give like given for degree, but we have to refer to the table. If it is 5%, then what is the table value? We should know how to refer to the table. For degree of freedom 1, 5% value table is 3.84. For degree of freedom 1, 5%. 5%. So what was the value? 3.84. 3.84. So you should know how to refer to the table. Now let us begin with, let us test whether there is any difference in the efficacy of these two types of treatment. Whether there is any difference in the efficacy of these two types of treatment, new treatment and the conventional treatment. Now, hypothesis. There is no significant difference between the new and the conventional treatment. There is no significant difference in the efficacy between the new and the conventional treatment. You can say like that also. The alternative would be there is significant difference. Now, the level of significance is alpha. How much error you want to give? Alpha 5%. Chi-square test statistics is used. Here chi-square test, now it is contingency table of two dependent variable. Two in nominal data, again here nominal. Here only category, favorable, unfavorable, only category. Here data is like this, favorable, unfavorable. This is just a category, nominal. And two sample, one sample is for treating with a new treatment, another sample is conventional. So this is for two independent sample, and so chi-square contingency should be used. Chi-square contingency should be used. So 5% and for degree of freedom, 5% for degree of freedom, the value is, so if the calculated value of chi-square is less than 38.4, accept the null hypothesis. And if the chi-square calculated is greater than 38.4, reject the null hypothesis. Again, let me tell you, some senior research scholar, they want that, don't say accepted. You use the word not rejected. Instead of accepted, the most preferable word they are suggesting is not rejected. Okay. Now, calculation. For the cell 1, this cell 1 means, this one is cell 1, C column 1, row 1. Cell is the C11 means column 1, row 1, 140. For this, you want to find the expected value. This is observed. What will be expected will be you multiply this and this divided by 250. For this 60, what will be expected? This total 80, 200 divided by 250. And for this is expected value for this cell. Expected value for this particular cell, what will be the, this 20 is the observed value of this particular cell, but what will be expected? This total divided by grand total. Row total, column total by row total divided by the grand total. This will give you the expected value. So these are observed. For this observed, you have to find expected value. For this 30, for this particular cell, you have to find the expected value. This is observed. For this 20, you have to find the expected. How you find it? For this expected value will be, say, let's go there. 140, observed. For this expected will be column total 200, row total 170, 200 into 170 by 250. Now you go here. Expected 1, first row, first column. Row total, column, row 1 total, this one is 1, row 1, column 1. So row 1 total, column 1 total divided by grand total. So 136 is expected. Then this row number 1, column 2. Row number 1, column 2 is this one 30. This row number 1, column 2 is this one. For this, you have to find the 170 into 50 by 250. For this, 170 into 50 by 250, 34. So likewise, you calculate expected, then you make a table. For chi-square, easy, very easy for making a table. OE, 140, 136. Expected you have calculated. Observe that you have got, expected you have calculated, then this is chi-square. E whole square by E. Summation of this is the chi-square. Summation of this is the chi-square, 1.8376. Then what is the conclusion? This is less than this calculated is less than the table value. Table value that we have formulated in the decision rule. In the decision rule, we said 3.84. Now, this calculated chi-square 1.83 is less than 3. So, null hypothesis is accepted. So there is no significant difference between the new and the conventional treatment. There is no significant difference in the efficacy of treatment between the new and the conventional treatment. So new treatment or traditional treatment, there is no difference at all. So this is all about now chi-square. Limit remain 1 square, 1 phi. Chi-square for one sample. So that is called chi-square goodness fit. A chi-square for two sample dependent. There you will have contingency table. Contingency table. There your degree of freedom will be r minus 1 into column minus 1. Now for D is degree of freedom. For D, this one, how many rows? 2 rows. How many column? 2 column. For these particular rows into column, 2 rows, 2 column, degree of freedom is r minus 1, c minus 1. So degree of freedom is 1. So degree of freedom and the alpha value is the reference point. So you should know how to calculate degree of freedom. But for only one sample, it is n minus 1. You have 2 samples here, and again it is arranged into rows into column contingency table. So how to calculate degree of freedom? R minus 1 into C minus 1, 2 row, 2 column, so 1. Clear? And if these 2 samples are dependent, then you should go for McNamara test. But I will not be covering that. If the samples are independent, then contingency table. If the samples are dependent, then go for McNamara. Now for t-testing. So earlier, as I mentioned that SP data is statistical method by SP Gupta, then the Levin. So all these things, they say that t-test is being used for sample size less than equal to 30. But nowadays, what is used for the large sample size also used for the for large sample size also we are using the t-test. What can be applied for this small sample size, it can also be applicable to the large sample size. With that, you will not find Z testing in the SPSS. Earlier, for small sample size, you can easily calculate standard deviation. You can easily calculate mean. So t-test was being done enough. For large sample, well, it is very much difficult to calculate standard deviation or mean. So Z test was being used. So now let's begin with t-testing. Sample size earlier, nowadays, in SPSS, theoretically this is but SPSS, even a sample size is greater than 30, we are applying t-test. There is no problem. So conditionally sample the standard, either you know the population standard deviation or standard deviation of the sample, or standard deviation of sample can be easily calculated. If you calculate the standard deviation of sample, then you can estimate that as a sample, as a standard deviation of the population. Either given or either you can calculate from the sample, the standard deviation. Metric data are those data collected on metric scale. What are the metric scale? Interval scale and the ratio scale. And these are quantitative in nature. Nominal scale are qualitative in nature. So metric data are those data collected on interval scale and the ratio scale. And these are quantitative in nature. And general formula for t-test as well as for z-test is this: mean minus mean. Here this is, you see, for one sample t-test, you'll be referring to the population mean. So this is the assumed population mean. The mean of the sample, mean of the population divided by AC, standard error. For z-test also, for two sample, mean of the sample 1 minus mean of the sample 2 divided by SC, standard error. So this is general formula. When you are talking about 2 samples only, if it is more than 2 samples, you have to go for Anova Test. For 2 samples only, then when you are talking about, as I already mentioned that, when you are talking about metric data, you can think of only finding correlation R, or you can think about comparing the mean between the 2 samples, mean income, mean anxiety between the mean anxiety between the male and the female, comparison, or mean income, and so on. So general formula remains the same, but how you calculate standard error will be different from situation to situation. But same formula. But if you look at the peculiarity, same pattern is there. So mean minus mean, t-test and the z-test are mean for comparison the mean. So For two sample, sample one mean, sample two mean. But if you're for one sample, then given sample mean and a population mean. Clear? So this thing. So general formula is this: the mean of the sample, mu is mean of population, and your SE is standard error. How you calculate standard error? Standard error is standard deviation of population by root over n. And remember that your standard error is also related with your alpha. So how much error you are allowing? How much error you are allowing in your testing hypothesis is decided by the alpha. Alpha, and this standard error is checking how many error by chance is here. X minus, see, you look at this, X minus another mean, some value will be there. In that some value is a variation, total variation. Now it is being divided by the chance. By chance, you're dividing the total by chance. Now, if it is equal or less, then the difference is by chance. But if it is more than the by chance, then the difference, it also contains true difference. Why is it divided by here? This standard error is because of the sampling fluctuation by chance. This standard error is by chance, but here difference is x minus mu is the true difference. In that total difference, you have true difference plus difference by chance. When you divide it, then it's going to be, if it is more than one, then you can say that, oh, more than one, then there is true error, true the variation is also there. But how many chance? When you're dividing is indicating how many error by chance you are going to accept it. Beyond that, you are going to reject it. So this standard error is dividing the total difference. It has a meaning inside. Why it is dividing? It is dividing to see how many errors are there and up to how many error. Alpha 5%. 5% is the allowable. So it is indirectly checking how many errors are there by dividing. Now, case to test the difference between the mean of the sample and the population mean. This is for one sample. For one sample data analysis, even in the SPSS, you have to put the mean of assume mean of the population. One sample and then one sample t-test is there. But in the one sample t-test, mean of the sample is there, but mean of the population you have to fit. You have to fit from outside. That will be the mean of the population. Now here, mean of the population to test the difference between the mean of the sample and the population mean. And how you calculate the standard error? How we calculate the standard error is here, standard deviation of the sample divided by root over n. Standard error of the sample by root over n. So you can easily calculate the standard deviation of the sample. Sample size is very small, so in that you divide it by n, total number of observations. Then you get a standard error, and you divide this by the standard error. Normally, standard error is equal to standard deviation divided by root over n. Now, when you don't have the standard deviation of the population given, then you can use the standard deviation of sample here to calculate. You look at this definition. A manufacturer of a certain make of electric bulb claimed that his bulb have a mean life of 25 months. A random sample is being given. A random sample of 6 such bulbs have get the following values. Can you regard the producer's claim to be valid at 5% level? Here it is asking us to test whether the bulb lifespan, the owner is claiming 25 months. Lifespan of the bulb claiming it to be 25 months is valid or not, on the basis of sample data, on the basis of evidence, on the basis of sample data or evidence that a 6 bulb have been observed and one has 24 months, 26, 30, then this. On the basis of this information, you test the claim made by the producer that his bulb's lifespan is 25 months. Or in reality, for the research work, mean income of the sample you have found 25 months. The mean income you found 22. Mean income of the sample survey. But statistical data tells that mean income is 25,000, and another you found 22,000, yearly or monthly, whatever the case may be. So statistical data says that mean income is 25,000. So my sample data says that historical mean income is 22,000. So is there any significant difference or not? You can test using this formula. One is population historical data. Then you can say and your sample data. When you want to compare it, use this one sample t testing. Use this one sample t testing. Now we are going to see the claim of 25 months is valid or not. The claim made by the producer that my bulbs are having a lifespan of 25 months is valid or not. Now, then what is null hypothesis? You can say wording null hypothesis, the claim made by the producer is not valid. So null hypothesis is always no, not. Or you can say null hypothesis is not different from the, see, equal to means not different. Not different from 25 means not different from 25. Not different means almost equal to 25. Say, always what by what we say no, not. When I say not different from 25, null hypothesis is the mean life of bulb of the producer is not different from 25. Not different means equal to 25. And alternative hypothesis is different from 25. Now, with the help of the sample data, we're going to test this, whether it is valid or not. He claimed that that mean lifespan of our bulb is 25. So let us start with null hypothesis that he claimed he's claiming 25, so not different from 25 months. Now, the test is says two sample. Here is one sample, 5% rejection region. Degree of freedom here is n-1. So six sample data was 6 minus 1, 5%. You look at the t testing t table here. The degree of freedom here is 5. Degree of freedom is 5, and then 5%. Degree of freedom is 5 and a 5%. So 2.015. Degree of freedom here is here one. So your sample size is 1, 2, 3, 4, 5, 6. 6 minus 1. 6 minus 1 means 5. 5% level. So significant 5% level. 5% level. So you refer to the table. 5%. The degree of freedom is degree of freedom 5. Then you are having two-tail test. So two-tail test will be how much? 2.571, no? 2.571. 2.571. So your 5%, was if two-tail test for a symbol like this. For a symbol like this, two-tail test. So 5% is divided into 2.025, 0.025, 0.025, 0.025, and then 5% degree of freedom. So value from the table is 5% two-tail test, you divide into 2.025, 0.025, and then degree of freedom 5, so 2.571. So table value is 2.571. So here, why we are dividing here? See, this table is for one tail test, but the symbol I'm using here is two tail test. So 5% should be divided into 2. When you divide 5%, when you divide 0.05 by 2, it is 0.025. So two tail test, the two tail test, 1.025 will be here, and another 0.025 will be here. Together 5%. So 0.025 for two tail test. So value is 2.571. So this one. Now let's calculate. You know how to calculate standard deviation? In the morning, I have shown to you the standard deviation for individual observation, the standard deviation for discrete series, individual observation for continuous series. Once you know how to calculate the standard deviation, but it is possible only for small sample size. For large sample size like 100, 200, how can you calculate standard deviation? So that's why when the small when there is a small when it is a when some sample size is very small, in those days t-testing was being done because you can easily calculate the standard deviation. So standard deviation formula for this is summation x minus x y squared by n root over this one by n. So you can calculate here. So standard deviation is root over x minus x square by, if the standard deviation is calculated from the sample is n minus 1. If the standard deviation from the population minus 1 will not be there. In order to differentiate whether the formula is for population or sample, it is for sample always divided by n minus 1. But for population, standard deviation of the population, there will be no minus 1. So standard deviation for sample is this one. So once you got the standard deviation, then you can calculate a standard error. The standard error is a standard deviation sample divided by root over n. The standard error is divided. Once you know the standard error, you put here. So this is mean of the sample 23, mean which was claimed by the producer. So this one. So this is minus, you can see your dumbbell cell normal distribution is 11, right? If left is negative, right is positive. So for the calculation, always you take absolute value. Absolute value is 1 point, when you divide this one, minus 1.084. But by taking the absolute value, you ignore the minus. Always take for the absolute value minus by taking the mod. So 1.084 is the table value, calculated value. Now, standard, since the calculator is 1.084 less than this one, null hypothesis is accepted or not rejected. Accepted means not rejected. There is a claim made by the producer is valid. In other words, the mean life of the bulb is 25 months. The claim made by the producer is valid. So this is for one sample test. So like you have a statistical data, so the statistical data from the directorate, and then your sample data is there. Then you can compare in terms of mean income, in terms of fertility, in terms of whatever the case may be. You can compare with your sample with the available statistical data. So one sample. Now case two tests that within two means of sample, mean of independent sample. You have two means. Two sample which are independent. Two sample which are independent. Now, we may be interested in testing the hypothesis that the sample come from the same normal distribution. Now, suppose stress level, the anxiety of the women teachers and anxiety of the male teachers, two sample. So whether there is any significant difference or not. I wanted to see whether there is any significant difference in the mean score of anxiety of the women teachers and the male teachers. So their mean income is this, mean anxiety is this. So subtract it and then divide it by the standard error. So we're going to see whether this difference, there may be some difference, whether difference is significant or not. Clear? Two sample, lady teachers and the male teachers, their anxiety level during the COVID has been measured. So one anxiety level of the male is 35, anxiety level of the female teacher is 30. So difference of 5. In the difference of 5 is going to be divided by the AC to see whether this difference of 5 is by chance or not. If it is by chance, then you will come to the conclusion that both the male and the female teachers have the same level of anxiety. But if the difference is significant, then you may come to the conclusion that male teachers are having more anxiety than female teachers during the COVID pandemic. So in that case, you can apply this one. T-testing using two sample. T-testing of two sample. Now, always it is difference is divided by the standard error. Then, as I have said, standard error is always root over, always standard deviation by divided by n. Now, if this is root, suppose there is a square. So this can come out. Let's assume that the formula, the general formula was standard deviation divided by root over n. Now suppose this square, you think that this square is removed, then this standard deviation can come out. The standard deviation will be upstairs. Then two samples, so 1 by n1, 1 by n2. So this root over is there. So same structure. The same structure, there is standard deviation divided by the root over n. So standard error will always have the same structure. And you know that this standard deviation is a combined standard deviation of the samples. Pool or combine standard division of the two sample, female teachers and the male teachers, combined pool. How will you calculate it? You know how to calculate standard deviation in x minus mean, variable minus mean whole square divided by n. There was a standard deviation. Now this pool, how you calculate this pool? Same formula you did here, but instead of dividing by n only, so two samples, so n1 plus n2 minus 2. It's little modified. Two sample, this standard deviation is a combined standard deviation or pool standard deviation of the two samples. So you know how to calculate standard deviation. The formula for standard deviation for x1 was x1 minus x1 bar whole square by n. For another was x2 minus x2 bar square by n, whole square. This 2 is whole square by n. So here this summation are being clubbed together, divided by n1 plus n2. It's little modification, but the structure remains the same. There is standard error, or standard error is standard deviation by root over n. Here also the standard deviation is sigma summation x minus x bar square by n. Structure remains the same, but remember it is combined. Now, once you know this, two types of drugs were used on 5 and 7 page chains for reducing their weight. Big, fat people like us. So we wanted to reduce we are moving market. As we go to the market, people rushing us, telling that there is a clinic and there is a agent which has medicine or which has something to reduce the weight. So fat people are the moving market. Whenever they move down the street, all the people are after them, giving them card. Please, if you have any problem of the weight, or if you want to reduce the weight, please contact those. So cards are being given. So two types of drugs were used on 5 and 7 patients. Drug A is the important one. Drug B is the indigenous one, and the decrease in the weight after using the drug for 6 months. For 6 months was given below in the table. Is there any significant difference in the efficacy of the two drugs? So drug A, imported 5 people, continuously they are being examined for 6 months. 6 months. So 1, 2, 3, 4, 5. So 5 persons, drug A. Then 7 persons, 1, 2, 3, 4. These are 2 samples. Now these 2 samples are independent of each other. One is treating with drug A, another is treating with drug B, independent of each other. So my second case was to test the difference between means of 2 samples. Second case, 2 samples. So you know this one, 2 sample. You have to calculate the mean of sample 1. You have to calculate the mean of sample 2. Now you have to calculate the standard error. For calculating the standard error, you have to calculate the standard deviation. This is the combined standard deviation. You have to calculate the standard deviation. For calculating standard, you have to refer to the table. Once you know the formula, everything can be accommodated in the table while you are making the calculation. Now, step 1, there is no significant difference. There is no significant difference in the efficacy of the two drugs. There is no significant difference in the efficacy of 2 drugs. Step 2, alpha is equal to 5%. 2 sample t-test, 2 sample t-test. Rejection region, if you look at the degree of freedom here, degree of freedom is n plus 1, n minus 2 by 2. 2 sample, for 1 sample it was n minus 1. For 2 sample now, another n minus 2, n minus 1. So clubbing together, n plus 1, n plus 2 minus 2. Here had been only 1 sample, n minus 1. Now 2 sample, n1 plus n2 minus 2. So there is a logic in that. So if you know the logic, remembering the formula is not so difficult. One of my friends told me that it is not necessary to remember everything, but we should know where it is available. Even for any topic, any formula, something. So we should know where it is available, where it can be located. But remembering everything is not so necessary. He told me that, but I don't know. But so far as possible, try to remember and try to know, locate where exactly it is available. So if you know the concept, if you know the formula, then easily you can do the testing. So there is no significant difference in the efficacy of the two drugs. So alpha 5%, the rejection reason, so is if the calculated is greater than this, then less than this, then is not rejected or accepted. Some people want to say instead of accepted, not rejected, okay, not rejected. And then if the greater, then greater over here, so no is rejected. So calculation part, if you know the formula, so how to calculate the standard deviation of these? So this is how to calculate the standard deviation for drug 2. So deviation square. First you make a deviation, first you calculate the arithmetic mean, then deviation of this series, then deviation square. First calculate the arithmetic mean of this, the deviation from the mean, then square. Now mean you can calculate summation x1 by, you calculate the arithmetic mean, then deviation calculated, now standard deviation, you can easily, this is combined standard deviation. The formula I have just mentioned, combined standard deviation, calculate it. Then once you know this, you can calculate the standard error. The standard error formula is there, sigma square, this one. You know standard error now. Once you know the standard error, then here, bring the standard error here. So mean was what? Mean was 12. Mean weight loss of the sample was 12, 1. Another sample is 11. So 12 minus 11, then by dividing by standard error, now 0.736, 0.736. Now what was the condition? Calculated value was 2.228. Now it is less. Your calculated value is less than the table value. If it is less than, accept the null hypothesis. So S0 is not rejected. There is no significant difference in the efficacy of the two drugs. Please don't get confused. Instead of writing accepted, I am writing here not rejected. So many senior teachers prefer to say, instead of accepted, they prefer to say not rejected. Why? The argument was that since we are doing the calculation on the basis of sample, not on the basis of population data. There was the logic. So I also mentioned here not rejected. Now, another interesting thing. So last part of the t-test. Last part of the t-test is that two samples, these samples are dependent sample. Two samples, these samples are dependent sample. For example, to find out the effect of training of employees. The training programs are being done, whether it is effective. Right now, you're attending this particular program, whether this program is effective or not. In that case, dependent sample means what? Before the training program, they are being evaluated. After the training program, they are going to evaluate it to see whether the performance has been increased or not. In every organization, the employees are being sent for training. So before the training program, what is their knowledge or how is their performance? After the training program, what is their knowledge or what is performance are being measured to check whether the training program was effective or not, to find out the effect of coaching classes, whether the coaching class was useful or not, whether the coaching class was useful or not. In such situation, you'll be using the two sample, independent sample. You'll be using dependent sample. Dependent sample means what? Only one sample is being used again and again. In both the case, you are using the same sample. So they call dependent sample. I'll show you another, this one. Another one. This one. Before the application of one, say a medicine, you can say see, so a beautician before the treatment by the beautician, these are the looks. After the treatment, these are the looks. Whether the beauticians claim that the treatment provided by her is effective or not. You can use the T-related test. This heroin was earlier this one, after the makeover this one, after the makeover this one, Aishwarya, no, Aishwarya, your that one. So after that, your Miss Universe, this one, then after that this one. So before and after, before the treatment, these are the thing. After the treatment, these are the thing. Whether the treatment was effective or not, of a particular coaching class, whether a particular coaching class, was effective or not. Now, in that case, when you are interested to know the effectiveness of the treatment, then T-related tests, or you can say T-dependent sample test. You can use T-related. You can call it T-related test. T-related test. So dependent sample test, or you can say related t-test, test of significant difference between the two sample. So the formula is d bar by SC. Here it is mean of the difference. D bar is mean of the difference, and SC is, as usual, standard error is a standard deviation by root over n. A standard error is always a standard deviation divided by root over n. And then this standard deviation is a standard deviation of difference. How you calculate standard deviation difference is d minus d bar. This is here square. Summation d minus d bar whole square. How do you calculate the standard deviation? X minus x bar whole square divided by n minus 1. So likewise, standard deviation of difference. This is the pooled standard deviation. After you calculate the pooled standard deviation, calculate the SC, then difference, mean of the difference. Mean of the difference, you divide by SC. Now then you get the T value. Compare with the table value. So this is very much useful. After the treatment, before the treatment, things are being measured. After the treatment, things are being measured. Then, so before advertising campaign, how much is the sale? After showing the advertisement to the customer, how much is the sale? So before and after treatment, this is very much useful for before and after. While you are designing a particular advertising copy and then you are showing to only few selected customers. Before, how do they remember the ad? After, how do they remember the brand? So before and after case. The question here, to verify whether a coaching in statistics improve the performance, a similar test was given to 12 participants, both before and after the course. The original marks recorded in alphabetical order of participants were given below. Test whether the coaching was useful. This is particular coaching program on statistics. Before the statistical program, students are being tested regarding some numerical, so tested. And then after the coaching program, again they are being tested. These are the score. These are the score. So on the basis of this score, you have to say, after examining it, you have to say whether the coaching was effective or not. Whether the coaching was effective or not. So null hypothesis, the coaching was not useful. I always say null hypothesis, you begin with no, not. The coaching was not useful. Many students remains the same as it is. Even after the coaching classes, the student remains the same as it is. So the coaching was not useful. Then the coaching was useful. The alpha again 5. See, remember always, level of alpha indicates up to what error you are allowing. 5%. That means out of 100 occasions, I may be rejecting a true hypothesis 5 times. So alpha 5% is the allowable error that you are giving in the procedure of testing. So related sample t-test, reject. So degree of freedom, you have only one sample, so n minus 1. N is 12 minus 1, 11. Then the 5%, you refer to the table of t value, you will get 2.228. So 11, 5%. 11, 5%. 11, 5% means 0.25. 11, so 2.201. You can easily refer it. So 2.2, this is 2.201. Just now we have seen it. 2 point. If the calculator is less, accept it, accept the hypothesis, or is not rejected. Not rejected, accepted, same. If the calculator is greater than, reject the hypothesis. The calculation, before, after, difference, make a difference. 53 minus 44, 9. 38 minus 40 minus 2. This difference, then find the limiting mean. This difference summation is 60. So how many are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Divide 60 by 12. Divide 60 by 12. So it comes out to be how much? 5. 5. Now go back. So this is the difference. 9 minus 5, 4. Minus 2 minus 5, minus 7. 8 minus 5, 3. So D minus D bar. Then you make a square. D minus D bar square. Then you make a summation. So you make a summation here. D minus D bar square. So calculation here. Just fill into the formula. So D bar, you know 5. D standard deviation, you know this. AC you calculate. Then T is 3.471. And this is greater than your table value. So greater means is not is rejected, and alternate hypothesis is accepted. Is not is rejected, and alternate hypothesis is not rejected means accepted. There is coaching. There is the coaching was useful. 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 The same thing you can do it for this. A beautician claimed that he can bring around remarkable changes in the face of the people who comes to him for makeover. To test these, 10 people were considered. They were judged by an expert before the makeover and again after the makeover in a 10-point scale. In a 10-point before, the first lady was getting before 6, later 7, 6.5, 7. Then another lady was getting 7, but after 5.5. So this is the score before the makeover, after the makeover. The question is, there any improvement? Is there any improvement? Is the improvement significant? The question is the improvement significant from this to this? Null hypothesis, the improvement is not significant. You can start with saying that improvement is not significant. You can start saying that improvement is not significant. Then you do the calculation the way we have just done. Difference D, find the mean, then variation from the mean, then standard deviation, how to calculate it, compute it, then you'll come to the conclusion whether improvement was significant or not. Now coming to the Z test. See, normally in SPSS you will not find Z test. All those tests which we apply in the T test are also being applied for Z test. Only difference earlier was when the sample size was greater than 30. Now even for sample size greater than 30, say 90, you use T test. The same thing you can use. So whatever is applicable to T test now is applicable to Z test also. So Z test can be applied to T test. What applying for Z test now? Those in the T test, you will get the same result. The formula are the same. Mean minus mean.
Sir, sorry to interrupt, sir. Your voice is breaking again.
Sound okay?
Sir, voice is breaking, sir.
Weather problem. Is it okay now?
Now, okay, sir.
Oh, I have removed the video. Now, my dear friend, earlier for large sample now you applying for Z now applying the T-test now. Z-test you will not find in the tests because what the same sample you are using the
Sir, problem not solved yet. Sir, can you join afresh?
Completely.
Okay, sir.
So, my dear friend, here we segregate into small size and large size. Now in segregation. So whatever we applied for the details are also applied for the condition that earlier. That is even in theory right now also in this book for sample size greater than 30 method data means data collected on interval scale and slow scale are used for testing. Now I have to complete it now. Wait. For to case to test the difference between sample mean and population similar to your earlier t testing. Sample mean and population, the same formula, mean of sample, mean of population, standard error, standard deviation of population by n. See, then the sample by n. Case one was same formula, and
Sir,
Dibo,
sir, please.
okay. So case one again, you're in. Dibo, is it okay?
Sir, sometimes your voice goes away. So
Dibo?
can you just verbally summarize the topic, sir?
Okay, it's okay now. It's okay.
It's okay, but sometimes it goes again, sir. When you start, it goes away.
It is
It's very fluctuating, sir.
Okay. If there is any problem, then just mention. Okay.
Okay, sir.
This case one was similar to t-test case one. You can apply t-test thing. Second case, to test the difference between two sample means. Between two sample means, similar to your t-testing of two sample mean. S1 minus S1 mean minus S2 mean by SC. And SC is calculated by this similar. So, Dibo?
Sir, it's coming, sir, now.
Okay. So, second case was similar formula, similar t-test of two sample. Clear? Then, but this is a special case. This is a special case for Z-test. This in terms of proportion. If you want to test in the proportion, and if you know the formula, how to calculate SC, then the rest of the problem is solved. So for a particular proportion P1 minus P2, this is the Z-test. So this is one special case different from the t-testing. This is for case of proportion. This is a special case for Z-testing that you can do it. Now, for what situation you can do it like this? You go to the form question. Before an increase in the excise on tea, 400 people were found to be tea drinker. In the sample, 400 persons are known to be tea drinker in a sample of 600 people. Do you think that there has been significant decrease in the consumption of tea? Do you think that there has been a significant decrease in the consumption of tea? So this, if you look at this is going to be one tail test. Left decrease means it is going to be left tail test. And proportion here, the first proportion is 400 by 500. Second proportion is 400 by 600. before the increase, 100 persons were found to be the drinker in a sample of 500 people. After an increase in the duty in the duty, 400 persons are known to be the drinkers in a sample of 600 people. So in such cases, you can apply this one. Suppose why there is sound coming?
It's okay, sir. Now you can continue.
So many sounds are coming. As if the connectivity has been removed. Now for this case, okay. Likewise, this is a special case of Z. There has been no significant decrease in the consumption. There has been significant decrease. There has been no significant decrease. Likewise, if you know the formula, the proportion, earlier one was before the income tax 400 by 500. After the income tax, excise, after the taxation 400 by 600. So if you know this proportion, then easily you can come to the conclusion there has been significant decrease increase in excise duty. So after the increase in excise duty, whether the consumption of a particular product has been decreased or increased, you can easily do that. Now, so earlier what we did for Z test, now you can apply all those things in the T testing. Almost all the same, but some special cases are there for Z test, but this has to be done manually, not available in the spaces. I will show you one thing. There is regarding the F test. Divo, just give me 5 minutes. Divo?
Yes, sir. Okay.
I'm completing within 5 minutes, right? Because of the rain. Is it visible? I'm sharing one. Is it visible? I'm sharing word. Is it visible?
Visible, sir. Visible.
What, analysis of Anova?
Yes, sir.
See, my dear friend, when the number of sample is more than 2, you want to test whether the stress of teachers, whether the stress of this one, stress of the employees. So lower level, upper level, whether they have the same stress or not. So you are having 3 samples, one lower level, middle level, upper level. So mean score have been calculated. After calculating the mean score, you want to see whether there is a significant difference in the mean score or not. So when the sample is more than 2, earlier for 2 you have done T testing. Now if it's more than 2, you can go for Anova. So Anova, but remember assumption. There are many assumptions of which normality you have to test the normality. This has to be done by Sifar and then this one, Kamogrosminov, and then your this one, skewness, kurtosis, with the help of skewness, kurtosis, and then Shapiro. You can test the normality, and then homogeneity. Homogeneity is standard deviation 1 squared equal to standard deviation 2 squared. That means standard deviation of all the sample. Variance of all the sample should be equal. For sample 1, you calculate standard deviation, then square equal to another sample. Standard variance within each group should be equal for all the group. Now, earlier normality was very difficult to calculate manually. Now, normality and homogeneity in SPSS is easily available. If your data fulfill this, then you are ready for Anova. Otherwise, don't go for Anova test. Anova is when it is more than 2 sample. Up to 2, you are having Z test or T testing. But if it is more than 2, Anova. And I have already mentioned that for numerical data, only you can think of comparison of the means or correlation. So for Anova, it is more than 2, then you go for Anova. Anova 1 way is there when you are using only 1 variable. Anova 2 ways there for you are having 2 variables. But again, when effect of 1 variable you want to control it in Ankova, you have to use Ankova. Now for Anova, these 2 assumptions, normality and homogeneity should be fulfilled. Difficulty, why there is sound coming? The king, the network disconnection sound.
No, sir. No, sir. It's
No,
visible,
sir.
sir. Visible, sir.
It's visible and audible clearly.
Okay.
Sir.
So Anova is audible now.
Yes,
Audible.
sir. Yes,
Now
sir.
almost
Yes, sir. Yes, sir.
for more than 2 samples, go for ANOVA, and then before using the ANOVA test, you have to check abnormality and homogeneity. Now in SPSS, whether it is homogeneity or not, it is easily available. You can do it. There is the technique is available. The condition for applying ANOVA is more than 2 samples. Data are often experimental, but nowadays even a survey data are also being used for number one way when you are having only one variable. So you want to see whether the color packaging, whether the color of the packaging has something to do with the cells. Color packaging obviously of a particular product. Color of a particular product has something to do with the cells or not. One variable. Whether the cell of a particular product has to do something with the packaging plus price, then 2 variable. So if it is only one variable, then ANOVA one way. 2 variables, then two way ANOVA 2-way variables. Now when analyzing using only one test variable, this test variable may be only stress, anxiety, only one. Stress and anxiety, and then opinion towards the online teaching. So one variable only. But for example, a test to measure the sales of 3 colors of packaging. 3 colors of packaging, say 3 packages of coloring, 3 package, but a test to measure the 3 color packaging. Here the variable is packaging. Here the one variable packaging, ANOVA one way, like this. So packaging, red packaging cell 8, 10, 3, black packaging cell this. Open. You want to examine whether packaging has something to do in the cells. That means you have to use ANOVA one way. But in the case of 2-way, if the data is like this, you want to see whether on one side another variable, and you want to see whether there is difference in the sales because of the price or because of the color packaging, then 2-way analysis. But while you're analyzing the impact of color packaging, if you want to control the prices, then you have to use ANCOVA. In ANCOVA, you have ANCOVA one way, ANCOVA 2-way. Then you have to how many variables you want to control. ANOVA plus ANCOVA, you should know it. ANOVA simply analysis because depending upon the variable, but it doesn't control. But if you want to control the effect of another variable, then you have to go for ANCOVA. See, earlier we have analyzed numerically. Numerically these are lengthy same. But always you remember that in ANOVA then calculate the variance within the sample, calculate the variance within the sample. At the end, you have to produce, this is a summarized table. At the end, summarized table, sum of the square of within the column, sum of the square within the sample, then degree of freedom, mean square, the variation of F is this one divided by this, then table value. Then you have to compare. If table value is greater than or less than, accordingly whether it is significant, whether the hypothesis is accepted or rejected. So it is lengthy, but numerically we did it. So numerically we did it. It is short step. There are 2 steps. One is shortcut. Another is a lengthy method. In the case of shortcut like this, in the case of shortcut, first step 1, there is no significant difference. There is significant difference. Then calculate the variance within the sample. Within the sample means first you have to first calculate grand mean. After getting the grand mean, then mean minus grand mean. Then after that, for example, these are the formula. These are formula that you can easily do it. And then after this is summarized. You have to produce all those things in this summarized. This is the summary table of the ANOVA. Maybe one way analysis, 2-way analysis, whatever the way analysis is, you have to produce an end summary table. In this summary table, you have to add everything. Then you have to draw the conclusion. So shortcut method is also there. Number 1, sum of all the items sum of all items of various sample. This is the formula. Then correction factor, so sum of the square, then sum of the square between the sample. Then after calculating all these things, ultimately here, source of variation within the sample, SSC, you have calculated SSC or you have calculated. So two or two variables. So FTS manually we did it, but to do it with help of SPSS. But remember that before applying the ANOVA, make sure that mainly two assumptions, there is normality and homogeneity are being verified first. Once these two assumptions are being fulfilled, then go for ANOVA. Otherwise, don't go in because during the final viva we ask, you have applied validity to parts. Have you tested it? They said no. Then how you apply ANOVA? When assumptions are not being fulfilled or when assumptions are not being tested, then why at all you apply the ANOVA? These are the questions that we ask. So I do believe that in the second phase of your program, there detailed analysis of spaces will be done, and at the end, by tomorrow or by the other tomorrow, how to fit the data in the spaces will be started, and accordingly, you will know. Those who are totally new in this field, you will come to know everything about how the analysis is being done by spaces. Without the theoretical knowledge, how you calculate the degree of freedom, and then what is level of significance, and all these things. Without knowing the theoretical background, it's very much difficult to draw the conclusion. So first go through the theoretical aspect, then go for spaces. For spaces, there's only one step. Or you just press the finger, and all the results will come out. So thank you very much. Hope that you, to some extent, you may have the idea. So this particular program will give you just awareness. Go back home and then try to know more about this and attend the next program where you will be fully introduced to SBA. Thank you very much. Thank you.
Thank you, sir. Thank you. Sir, actually, the topic is so vast. Actually, it requires at least 6 months to finish the entire course.
But at least
awareness covered in 4 hours.
At least awareness has been given, so let them start.
So even the participants were asking for the materials. If you can provide the PPT and document, then they can somehow read it and find out the missing point.
I'll give you the. I'll provide the materials. I'll provide the materials. Don't worry. I'll send it to you in a PDF form.
Okay, sir. Okay, sir. So quickly, I request Vaniji to provide the vote of thanks to sir.
Okay, sir. Okay, sir. Sir, please, one minute. Good morning to all. I am Ms. Vanishri K, research scholar from VIT Business School. I deem it a great honor and privilege to propose the vote of thanks to this august gathering here. Let me first of all start by giving glory to the Almighty God for making this virtual FDP a resounding success. First and foremost, I thank our course coordinator, Dr. Debjyoti Chaudhary, Assistant Professor, Department of Business Administration, Assam University, and Assistant Coordinator, Dr. Nilanjan Chakrabarti, Assistant Professor, Department of Business Administration, Assam University, for providing their unstinted support and hosting the event a grand success. I take immense pleasure in extending my sincere thanks to the resource person, Professor H.Ramananda Singh, Head of Department Business Administration, Assam University, Silchar, and former director, delivering a lecture on measures of central tendency, measures of dispersion, correlation, test of significance and its need and terminologies, test of significance, G-test, chi-square test, one sample t-test, two sample t-test, paid sample t-test, F-test, and thank you for offering us with thought-provoking inputs. I feel it a privilege to extend my heartfelt thanks to Department of Business Administration, Assam University. Last but not least, I thank Atal for being a platform providing training to enthusiasts. Thank you once again. Have a nice day.
Thank you, Vaniji, for providing the.
Thank you, sir.
So we are coming to the end of the session here, and we will meet again at 3 p.m. with the next resource person. And if you have any questions, specific question related to the topic that has been discussed today, you can directly send email to Professor Ramananda Singh. I'll share the email ID and phone number to you all. Thank you.